The title of the talk is Characterizing Nitrous Oxide Emissions from the US Corn Belt Using Atmospheric Methods. Whenever you're ready.
Ready. Is it getting hot around here, or is it just me? No, actually, the Earth's temperature is indeed getting hotter, and it's because of greenhouse gases, and it's becoming unsustainable for life on Earth. Greenhouse gases from human activity are causing the Earth's temperature to rise because these gases are trapping heat from the sun. One of these potent greenhouse gases is nitrous oxide, or referred to as N2O. N2O has 300 times more of a global warming impact than carbon dioxide, meaning it traps way more heat, making it an important gas to measure and mitigate. Its main source comes from agricultural soil, specifically when synthetic nitrogen fertilizer is applied. Now, the diagram on the left shows that when you apply nitrogen fertilizer to the soil, those nutrients get absorbed into the ground and taken up by soil microbes. These microbes then take those nutrients and essentially end up burping out N2O, which then escapes into the atmosphere. Now, agricultural activities have allowed the human population to rise exponentially. However, these activities have intensified all around the world, accounting for a total of 2/3 of anthropogenic N2O emissions globally. However, these emissions remain unquantified, and it's important to understand N2O in order to prevent further damage to the climate. So this brings me to, this uncertainty brings me to know that there have been a lot of measurements done at the small scale as well as in the lab, but measurements done in the regional and national scale of N2O emissions remain uncertain. And so my thesis aims to characterize N2O distributions of N2O across the farm to state scale. This brings me to the center of the slide. In spring and summer of 2021 and 2022, we flew a small aircraft with instrumentation to measure nitrous oxide and other greenhouse gases over Iowa and Nebraska, which are 2 states in the US Corn Belt. The figure in the middle shows the flight paths that we took, which cover a large area of this domain. And so we use this atmospheric observations in order to capture the variability of emissions from farms at the small farm scale. And we're also developing a new approach to statistically analyze these emissions across our domain to capture these hotspots of N2O. And so this brings me to the right side of the slide. We combine airborne observations with modeling output while using complicated math, probability statistics, to create emission maps in order to determine what percentage of emissions come from what percent of farms. This information will greatly benefit scientists and policymakers, as well as provide information for future farming management, monitoring needs, and climate action in order to help slow down climate change. Thank you.